Hello. In this video, I will work through calculation problems that involves IV pumps. So this is dosage still under calculation, and this is intravenous therapy, and we are delivering IV fluids using a pump. So let's begin. So example one says we have an order. Order is for 1 liter NS to infuse over 6 hours by infusion pump. At what rate, meaning final answer shall be in milliliters per hour, should you set the pump? Round to the nearest whole number. So we have to be in milliliters per hour. That's our final units, right? And yeah, so what would we do? At what rate, milliliters per hour, should you set the pump? Well, I need to do, before I start doing dimensional analysis, I do got to do a few things. First thing I'm going to do is convert liter to milliliters. The reason why is we want our final units to milliliters to liters. So we know that for 1 liter, it's going to equal to 1,000 milliliters. Okay. And then step two, um, because our final unit should be in milliliters per hour. So we know that for 1,000, for 1 liter is the same thing as 1,000 milliliters. So 1,000 milliliters for every 6 hours. So 1,000 divided by 6 is like 166.6666 milliliters per hour. You can write it horizontal, I mean vertical, slanted, or you can also say horizontal, right? Now the answer says round to the nearest whole number. The part of the question, yeah, part of the direction says so 166.6 rounded to the nearest whole number. This is then you look at this six, you look at the neighbor, it's definitely five and beyond, so it's going to be 167 milliliters per hour. So you can write it as slanted, or you can also write it completely horizontal. Okay. So yeah, that is example one. Okay, let's move on to example two. So example two, we have order is for ampicillin. Uh, this should be in not, is this the right question? I think I went too down. Oh, here we are. Okay. I thought I was going the wrong one. Okay. So example two. So order is for ampicillin 500 milligrams in 50 milliliters NC to infuse in 30 minutes. At what rate, meaning milliliters per hour, should you set the pump? Round to the nearest whole number. Okay, so our final answer has to be in milliliters per hour, right? So first, what I'm going to do is convert minutes to hours because we want it in milliliters per hour, right? So step one, I'm going to convert 30 minutes into an hour, which is easy, right? We know that in 1 hour, there's 60 minutes. So that's going to be 30 times 1 times 60. So that's going to be really, I mean, you probably knew that. That's like half an hour. And then step two, do our conversion. So we have it in hour. So we know that we were given 50 milliliters. So it's 50 ml over 0.5 hour. That's what our units want. That's what I want our units, milliliters per hour. Um, 50 divided by 0.5 comes exactly as 100, 100 or 100 over 1 milliliters per hour, or you could say 100 milliliters and then completely horizontal like that. Let's move on to example 3 then. So in example 3, we have an order of potassium chloride 40 MEQ IVPB. So IVPB stands for piggyback at a rate of 10 MEQ per hour. Okay, so our available is potassium chloride 30 MEQ per 500 milliliters NS. Round all answers to the nearest whole number. Okay, so we have an order. Let me read this again. We have an order of potassium chloride 40 MEQ IV piggyback at a rate of 10 MEQ per hour. And our availability is potassium chloride of 30 MEQ per 500 milliliters NS. Round all answer to the nearest whole number. So question A says, how many hours will it take for the order dose to be administered? How many hours? So our final unit has to be in hours. So uh, this one, it's not like dimensional ratio. It's just hours, right? So we start when we start we started with 40 MEQ, and then for we want hours on the top, and then on the bottom we want to get rid of this MEQ. So for 1 hour, how many MEQ? That is should be given. So they tell us that it was at a rate of 10. So this was given 10 MEQ per 1 hour. So as you can see, you can flip this. It's not going to make it wrong. You could put, this is what we have to do. We have to put 1 hour on the top and MEQ on the bottom. Okay, so this is 10. So for 1 hour, there's 10 MEQ, and then the MEQ cancels. You're left with 40 times 1 over 10, which is 4 hours. Okay, so part A says how many hours will it take for the order dose to be administered? It would take 4 hours. Okay. Part B says, at what rate would you set the IV pump in milliliters per hour to deliver the ordered potassium chloride safely? So this one you could do um, three method dimensional ratio. And can we do formula? Yes. Because yes. So at what rate would you set the IV pump in milliliters per hour? So that means our final answer has to be in milliliters per hour. So let's start with dimensional analysis. So let's start with dimensional. We start with what you have. We started with 10 MEQ times, and then I have to put MEQ on the bottom, and then milliliters on the top, right? And what is the relationship between MEQ and ML? Um, It said our availability was had a potassium chloride of 30 MEq per 500 milliliters. So 30 MEq or 500 milliliters, right? So there's yeah, this was given as we had 30 MEq over 500 milliliters. And as you can see, we had to flip it. Um, we had to put the milliliters on the top and MEq on the bottom because that's the only way we're going to get ml. And then if you multiply across, this is going to be 10 times 500. And then this is going to be 1 times 30. So 10 times 500 is 5,000. And then 1 times 30 is 30. And you get 166.66 milliliters per 1 hour. And that's our final units. So we're good. So yes, we only have milliliters, but for 1 hour, yeah, you could put 1 hour on the bottom. That will be our final rate. And they say round to the nearest whole number. So that's what I'm going to do. 166.66 as a whole number would be 167 milliliters per 1 hour. Now let's do the same problem using ratio and proportion. So write out your two fractions. And then you could put MEQ on the top and milliliters on the bottom, or vice versa, ML on the top and MEQ on the bottom. If you do that, just make sure this aligns with the top. So this has to be MEQ and this has to be ML. So for 30, we were given for 30 MEQ for 500 milliliters, and then we want to know how many milliliters, that's our unknown, for 10 MEQ. And then go ahead and cross multiply. So that's going to be 500 times 10 equals to 30x. So 500 times 10 is 5,000. Goes to 30x, and then divide this by 30, and you get x equals 167 milliliters per 1 hour. Okay, and then let's do the formula method. So to formulate is desire over half times vehicle. Okay, so our desire was 10 MEQ, and then we have exactly 30 MEQ, and our vehicle was 500 milliliters. And when you put it all together, you get 167 milliliters per 1 hour. Okay, let's move on to example 4. Okay, example 4 says we have an IV pump is running at 125 milliliters per 1 hour. How many hours, so my final answer has to be in hours, will it take for a 500 milliliter bag of NS to infuse? You can use dimensional analysis and ratio proportion, but I don't think it'll work for the formula method, right? So let's start with dimensional analysis. So we were given 500 milliliters times, and then I got to get rid of that milliliter, and then I got to put hours on the top because we want to find how many hours. And what's the relationship between hours and milliliters? They tell us that for 125 milliliters for 1 hour, right? So you can flip it. This doesn't change it. That's what we have to do because we have to put hours on the top and milliliters on the bottom. So you could say for 1 hour, there's 125 milliliters. For 1 hour, there's 125 milliliters over one, and then the milliliters disappears. You're left with 500 times one, and then one times 125. And that gives me 4 hours. Okay. And then let's do ratio proportion. So fraction, milliliters per hour, milliliters per hour. So um, we had a rate of for 1 hour, there was 125 milliliters, and we were given 500 milliliters, but we want to know the hour. That's our unknown. Cross multiply is 125x equals, so 1 times 500 is 500, and then divide this by 125, and you get 4 hours. Okay, let's do example 5. So example 5, orders for a heparin of 10,000 units and 250 milliliters at 40 milliliters per minute. How many units are infused over 4 hours? Round to the nearest whole number. How many units, so our final answer is in units, are infused over 4 hours? So let's start with dimensional analysis. So with dimensional, you start with what we have. So what did we start with? We started exactly with 10,000 units times, and then, okay. Okay, this is a little bit strange. Actually, let's start with, because yeah, you could start with 10,000. You could also start with your rate at 40 ml for 1 hour. And okay, so now what I have to do is get rid of this milliliters, and I have to get rid of this hour. And then somehow we have to have units. Okay, so for 40 milliliters for 1 hour, and for 4 hours, let's see. Um, wait, can we do it like this? No, I don't. Wait, here, let me start all over. So dimensional analysis, so we start with 10,000 units. And then I guess I could put milliliters on the bottom. You see why. So milliliters on the bottom times, and then milliliters on the top, and then hours on the bottom times, and then I have to get rid of that hours. As you can see, everything else cancels. Under hours, you can put a 1. See, the milliliters disappear, the hours disappear. That's what we want. Um, so what is the relationship between 10,000 units and milliliters? It said that is for heparin for 10,000 units in 250 milliliters. So what they're saying, for 10,000 units, there's going to be 250 milliliters. And then over here, what's the relationship between milliliters and hour? Well, they said that we had a concentration of 40 milliliters per 1 hour. And over here, what is the relationship between hours? Um, it said it was infused over 4 hours. So you can put four here. And then just multiply across because this is a fraction. So it's going to be 10,000 times 40 times 4 over 250 times 1 times 1. And you get, let's see, that's going to be 1, 6, 1 and 2, 3, 4, 5 over 250. And you get everything cancels. So you're left with 6,400 units. Okay, so that was dimensional analysis. Can we do the same problem with the ratio and proportion? I think we can. So with ratio proportion, you got to first figure out how many units are there in 40 milliliters per hour. So first, how many units are there in 40 milliliters per hour? So let's do this. So proportion, fraction, fraction, um, units on top, and then milliliters on the bottom, or vice versa. So if you do it this way, that means units has to be on the top and milliliters on the bottom. So 10,000 units, that's, and then 250. And then for X units, we don't know how many units, that's our unknown. And then for 40, so that's going to be cross multiply. That's 250X equals to 40 times 10,000. That's going to be 400,000. Divide this by 250. Divide this by 250. And you get 1,600 units. But we are infusing 1,600 units uh, per 4 hours. So it's going to be 1,600 units times, so 1,600 units per hour. And then we want to get rid of the hour. So we're infusing it for every 4 hours. And as you can see, that disappears. So you're left with 16,000 times 4 is now 6,400 units. Okay. Okay, so that wraps up for this video. I'm going to stop here.